Hello, I'm Professor Von Schmohawk, and welcome to YU. In the last lecture, we saw how two linear equations could describe parallel lines in the Cartesian plane. Another possibility is that the lines described by two linear equations can be perpendicular. Perpendicular lines are lines which meet at right angles. At their point of intersection, two perpendicular lines form four 90-degree angles. Perpendicular lines don't have to be horizontal and vertical. They may be oriented in any way as long as they meet at right angles. So how can we determine if two linear equations describe perpendicular lines? As we saw in the last lecture, parallel lines have the same slope. Likewise, we can tell if two lines are perpendicular by comparing their slopes. Perpendicular lines have slopes which are negative reciprocals of each other. So what does it mean for slopes to be negative reciprocals? We saw in pre-algebra that multiplying two numbers that are reciprocals of each other always produces the product of 1. Negative reciprocals can be created by changing the sign of one of the reciprocals. Multiplying two numbers that are negative reciprocals always produces a product of negative 1. So if the slopes of two intersecting lines are negative reciprocals of each other, the product of their slopes must be negative 1. And this tells us that the two lines are perpendicular. So why are the slopes of perpendicular lines negative reciprocals? To see why this makes sense, let's draw a line running through the origin and place a point on the line somewhere other than the origin. The slope of this line can be calculated using any 2 points on the line. So if we like, we can use the origin as one of the points. The slope is equal to the difference in the 2 points' vertical positions divided by the difference in their horizontal positions. Traveling from the left point to the right point, let's call the difference in vertical positions P and the difference in horizontal positions Q. So the slope of the line is P over Q. Now let's create a second copy of this diagram, rotated 90 degrees counterclockwise. Since the copy of the line is rotated from the original line by 90 degrees, the two lines are perpendicular. For the second line, the slope can once again be calculated from the difference in vertical positions divided by the difference in horizontal positions as we travel from the left point to the right point. This time, the difference in vertical positions is negative Q, and the difference in horizontal positions is P. So the slope of the second line is negative Q over P. These two slopes, P over Q and negative Q over P, are negative reciprocals of each other. We can prove that these slopes are negative reciprocals by multiplying them together. To multiply these two fractions, we multiply their numerators and denominators to create a single fraction. Then, moving the negative sign outside this fraction, and using the commutative law to swap Q and P in the numerator, we see that the numerator and denominator of the fraction are the same. So the fraction is equal to negative 1. These two slopes are therefore negative reciprocals of each other. This is true for any two perpendicular lines. That is, unless one of the lines is vertical, since a vertical line's slope is undefined. Using the fact that the slopes of perpendicular lines are negative reciprocals allows us to construct an equation for a line which is perpendicular to any given line and intersecting any given point. For example, if we know that the given line's slope is 1/2, then the slope of the perpendicular line must be the negative reciprocal of 1/2, or -2. We can then use point-slope form to write the equation of a perpendicular line through any given point. For example, let's say we are given the equation of a line and asked to write the equation for a perpendicular line which runs through the point 4, -5. Since the equation for the given line is in slope-intercept form, the coefficient of x, 3, corresponds to the constant m, the slope of the line. Since the slope of the given line is 3, the slope of the perpendicular line must be the negative reciprocal of 3, or -1/3. Knowing the slope and the coordinates of a point on the line, we can write the equation for the perpendicular line using the point-slope form. The constant m is the slope, -1/3, and constants x1 and y1 are the coordinates of the given point, 4 and -5. The equation can then be simplified by writing y minus -5 as y plus 5. We have seen two geometric relationships that can exist between lines described by linear equations. In the next lecture, we will introduce a powerful mathematical concept of finding solutions that simultaneously satisfy multiple equations.